Day 28, Honors Physics, Projectiles, problem number 13. So here's my diagram. And I'm picking point A. Well, point A is the launch location. This is the launch direction, approximately. That's the actual launch velocity. I could call that V. It has two components. It has the X component and the Y component, as always. In this problem, you can pick point B. There's two spots. I like to pick this top spot, but you could have picked point B down here, and I'll tell you how that would change some things. But it'd still give you the same answer. But point B up here determines some of the numbers I'm filling in way over there on the right in my two columns for horizontal and vertical motion. So I have a total distance of 60 meters downfield, assuming the ball is caught at the same height it was kicked, which is the assumption here. Maximum height of 20 meters. So looking way over to the vertical columns, if I pick point B as my top spot, as my final spot for my velocity, the vertical velocity is 0 at that spot. And that height at that point is plus or positive 20 meters. And I still have my negative 9.8 meters per second squared for my acceleration. If I would have picked point B at the landing spot, back down in the ground level, bottom line is my V sub F would have been negative V sub I, symbolically, and S would have been 0 because there would be no elevation change from the starting and stopping or landing spot. So this would have been 0. I like this particular version. You can do it that way if you want, because if you do the version I'm doing right now, over here on the horizontal, you have to put in 30 meters for your horizontal progress halfway through the problem instead of 60 meters. Once again, assuming symmetry, which we have with no air resistance, it's 30 meters from point A halfway through horizontally to the top spot, and then, but just looking at the horizontal motion, that's 30 meters and another 30 meters to get the total of 60 meters. So bottom line, what you will do here is you will take these values, use the uniform acceleration equations to figure out V sub I, which is half of what you're supposed to be accomplishing here, getting the vertical component, which this will be the vertical component of the launch velocity, and also figure out T here. Take that T value and plug it in here to get your horizontal component. So this will be your horizontal component using V equals S over T. That'll be the horizontal component of the launch velocity. Another question could have been, what is the actual launch velocity? In which case you would take the two components and Pythagorize them to get your launch velocity, and you could figure out the launch angle as well.